Hello everyone. In this video I will be telling you about computer graphic topic, that is transformation. So first of all, what is transformation? If I say okay, transformation in English, in normal English, transformation means that when we change from one state to another, that is transformation, right? So if I talk about graphics, then transformation is changes in orientation, size and shape are considered with geometric transformation that allow us to calculate the new coordinates. So that is transformation, in which we have to change in the orientation, in the size and in the dimensions. So that is transformations. And if I talk about, transformations are of four types basically. Number one is translation, number two is rotation, number three is scaling, and number four is shearing. So four types of transformations. I will talk in detail about every one in the just in few seconds. First of all, I am talking about 2D transformation. Now we have known that one is 2D and another is 3D. Now what is 2D transformation? Transformation with respect to x and y coordinates system are known as 2D transformation. That means in 2D there is only two axes. One is x-axis and another is y-axis. Okay, so translation I'm talking about first of all, because all these transformation, one is in the form of 2D and other is the form of 3D. So first I talk about the translation in respect to the 2D transformation. Number one was translation. So they say translation is a process of changing the position of an object. That means if you change a position of an object from x-axis to y-axis, it shifts from from x to y, then it is known as translation. So it just in equation form they have given that tx consider as translation factor in x direction and ty consider translation factor in y direction. Then x dash is equals to x plus tx and y dash is equals to y plus ty. So this is an equation form about translation. If I show in a case of just a movement is there from x to y, so that's only the translation. Then if I consider in the matrix form, you just take a P matrix, in a row column, in one is X and other is Y. So it is a column base. X you have kept, there, and Y just below that. Then you consider P dash is a changed, the object position when it changed position image. So P dash you consider and consider it as X dash and Y dash. Then translation you consider as TX and TY. So if I talk about homogeneous coordinate system, that means the position would be in a diagonal, there would be 1, rest all 0, and only the last digit would be considering tx and ty. So this is all about translation. Translation we have done in three forms. Number one in matrix form, other one is homogeneous coordinate system, in which diagonals are 1, rest all 0, only the last two is tx and ty, translation factors, and in the in the equation form. So next we come to rotation. Now what is rotation? In 2D rotation, an object is moved on a circular path, that is object is rotated by an angle theta with respect to the origin. Now this is very important. With respect to the origin, it has moved from the angle theta. So theta is assumed to be anti-clockwise and minus theta is assumed to be clockwise. Fine. So just rotation means, the axes are of course 2D since it is, so there are only two axes, one is x and y. So the object rotates, it gives circle in any other direction. So if it will be clockwise, then it is minus theta. If it is anti-clockwise, then it will be theta. So relationship between polar and coordinates, if I consider in form of equation, then equation for rotation would be x is equals to r dot cos theta and y is equals to r dot sine theta. And r is equals to under root of x square plus y square, and theta is equals to theta is equals to tan inverse of y upon x, tan inverse of y upon x. If I consider in a form of a diagram, you just consider one angle. This is y axis, this is x axis. So this angle formed between x and y, that considered to be theta, and if it moves to the negative, anticlockwise, then it means the value would be theta, and if it moves anti-clockwise, then it would be theta, and if clockwise, then minus theta, right? So there is equation of homogeneous coordinate in anti-clockwise, RHO. That means if I consider rotation, then it would be cos theta sine theta 0. I'm just reading the whole line, the row part. Cos theta sine theta 0 minus sine theta cos theta 0 0 0 1. So this will be in the form of equation if I consider in terms of anti-clockwise. Fine. If I consider in clockwise, the equation would be, clockwise was minus theta, right? So it would be cos theta minus sine theta 0 sine theta cos theta 0 0 0 1. So only the minus sign changes. If you say cos and sine, sine and cos is the same. In anti-clockwise, the minus sign would be in the second row of minus sine theta, and in clockwise, the minus sign in the sine would be in the first row of the second column, that is minus sine theta. Now lastly, we come to scalene. What is scalene now? Scalene is the process of expanding or compressing the dimension, that is size of an object. The new coordinates are calculated after multiplying the scaling factor, that is sx comma sy, into old points. Now it is just like if I have a rectangle image, I have squeezes out or I have extended it, like I have either I am shrinking it or I am expanding it. So that is called scaling. So the equation of scaling is x dash is equals to x into sine x, sx, sorry, not sine x, sx, and y dash is equals to y into sy. And if I consider in the form of matrix form, it would be x dash, in this form I would be, in a column form I am doing x dash upon y dash is equals to xy, x, y, x upon y, multiply by sx 0 0 sy. So this is the scaling factor. Fine. In this, just a small rectangle is there, I have expanded it and just become a larger image. So that is after scaling. If I talk about homogeneous coordinate system of scaling, then it is x dash comma y dash comma 1 in the form of row ways I'm saying. Then it would be x comma y comma 1 into s. In the diagonal form, the things would be written rest all 0 apart from the diagonal thing. Diagonal thing would be sx, sy and 1. So this is the scaling. Now lastly, we come to shearing part. Now what is shearing? Shearing transformations are used for modifying the shape of the object. Now you are just modifying in that. If I talk about about scaling, the thing was either expanding or expanding or contracting, right? But in the form of shearing, we are modifying the shape of the object. We are neither, we are changing the shape, maybe from rectangle to a square, we are changing the shape. So in it's of 3 types: x shearing about origin, y shearing about origin, and xy shear about origin. So in this, only the x-axis get changed. So in the equation for that would be x dash is equals to x plus ay comma y dash is equals to y. That means y remains unchanged, only x changes. So x plus ay we have considered. In homogeneous coordinate, if I talk about that would be x dash y dash comma 1 is equals to x comma y comma 1, and all the diagonal would be 1, rest all 0. Only the second row would be a, only because x-axis is changing. And if I consider y share about origin, that only the y thing changes. So the equation would be x dash is equals to x, y dash is equals to y plus bx, and x dash comma y dash is equals to xy, diagonal 1, and only the b is there in the y axis of the first row. So in homogeneous form, again x comma y comma 1, diagonal all 1, only b in the second row. So this is about y share. And lastly, the xy share about origin. that would be both x dash is equals to x plus ay and y dash equals to y plus bx. An equation form xy diagonal all 1 ba and x comma y comma 1 all 1 in the diagonals and b in the first row of second column and a in the second row of first column. So all this was about the 2D transformations. Thank you. I know you understand. Thank you and have a nice day. Thank you.